What's poppin', dogs? Mr. Allen here with a video on inverses of functions. We got ourselves a couple quadratic functions with domain restrictions. We're going to find the inverse of each one of these. We're going to graph them and list some characteristics down here. Let's get it poppin', man. First thing I like to do here is I write it as y equals x squared minus 5. Then I'm going to swap my x's and y's. So I got x equals y squared minus 5. Now we need to resolve this equation here for y. That'll be our inverse. So I'm going to add 5 over, get x plus 5 equals y squared, and then got a square root on both sides to get y equals plus or minus the square root of, let's make that a little longer, x plus 5. So we know now from prior videos or lessons or whatever that this right here is not going to be a function, because I'm going to have a radical going both directions and it will not pass the vertical line test. So that's where this guy comes into play, okay? I'm only going to be graphing half of this function. Is it going to be the positive or the negative version of this guy right here? Half of this equation, which will allow it to be a function. So what I'm going to do here is I'm going to write down f inverse of x equals, I'm going to leave a little space. We got our x plus 5 here. And we're going to decide in a moment here if that's going to be a positive or a negative in front. All right? So let's first plot our quadratic function that we're starting with. I'll do that in blue here, all right? In blue, boom, all right. So we've got x squared minus 5. Well, that just means it's a quadratic that would normally be at the origin here, shifted down 5. 1, 2, 3, 4, 5. Now my values are going to go up 1 over 1, up 3 over 1. That's a pattern of a quadratic unless it has a coefficient of 2. Then it goes up 2 over 1, up 6 over 1. You may have noticed some commonalities there. That is a pattern that will always hold true. So here, though, it says when x is less than or equal to 0, meaning I'm only going to go with this half of the function. So I'll have the ordered pair -1, -4. And then I'll also have -2 squared is 4, minus 5 is -1. We can continue going, but I think 3 points will do the trick here. So now I have this guy right there. I'm only doing the left side, or the negative x version, if you will. So if we're switching our x's and y's to get our inverse, here I'm going less than, right? For my x's, shouldn't I be less than 0 for my y's? And that's where our decision to do the negative comes in. And one thing to note here, all right, so you can remember this for each time because these are kind of tricky, is that when x is less than or equal to whatever number it is here, it's usually the number that is what's always the number associated with the x coordinate of my vertex. If that thing is less than or equal to 0, it's going to be the negative. If it's greater than or equal to some number, it's going to be the positive version, or it's going to be positive right here. So now let's go ahead and plot this wonderful radical function that we have here. Yes, it's a function now. It's going to pass the vertical line test. Well, we could do some ordered pairs here, or we could swap some x's and y's. Now with radicals, we look for perfect squares. If I plug -5 in for x, I'd get 0. The square root of 0 is 0. So it's just 0. Negative doesn't have any effect there. So when I plug in -5, 1, 2, 3, 4, 5, I got 0. If I plug in, let's say -4, because -4 plus 5 is 1, and I can square root 1, right? Square root of 1 is 1, but I got to make it negative. So -4, -1. And then what's my next perfect square? Well, that's 4. So what x value could I plug in here to get 4 inside the radical? If I plugged in -1 for x, -1 plus 5 is 4. Square root of that is 2, but make it negative. Boom, right down here. And we've got ourselves a negative radical function. And if you look at this thing here, and I draw in our wonderful y equals x line, we can see that it does reflect over that. Okay, had I drawn this guy here, I'm going to do that actually just for demonstration purposes. Right? If I had drawn the positive version, it would look like this. Do the blue and the orange look like they reflect over this yellowish greenish line right here? No, it looks weird, okay? So you can tell if you're like, something's not right, man. It's supposed to reflect over this line here. And this orange one certainly does not look right. So this is not right? That's not going to be the inverse there. Because of the restriction here, the domain restriction, x is less than or equal to 0, it is the negative version of that radical. Had it been greater than or equal to 0, we'd be dealing with the positive, and this blue guy would have been over here. All right, enough of these what ifs. I don't want to get too muddy here, but let's go into our domain range x and y intercepts. So for the blue one, the original, my domain was actually given to us. X is less than or equal to 0. What's my range? Well, it's always going above that -5, so it's going to be y is greater than or equal to -5. What about my x-intercept? Where is it crossing the x-axis? Well, that is interesting because it's like right in between there, isn't it? So let's say this. We can actually find out that that x-intercept, excuse me, if I set this equal to 0, okay? So I'm going to do so. I'll do it so right over here. Actually, you know what? I'll do it right here. So if I set 0 equals x squared minus 5, add 5 over, solve using square roots, I'm going to get x equals the square root of positive or negative, plus or minus the square root of 5. Well, which one is it? Well, since we restricted the domain to be over here, right, less than or equal to 0, it's definitely not the positive one. It's got to be the negative one. So my x-intercept is negative root 5, comma, 0. And then my y-intercept, well, my y-intercept here is at -5. So 0, comma, -5. That one we can see. That one's nice, all right? Now for my inverse in pink. Let's see here. My domain. Well, my domain is greater than or equal to -5, right? Y is greater than or equal to -5. Or sorry, x. Oh, my goodness. X is greater than or equal to -5. So here I'm starting at -5 and I'm going to the right. We can also see that the values here, they swap places. My range was greater than or equal to -5. Now my domain, which is x, very nicely written, x is greater than or equal to -5. Now for my range. Well, what's my range here? It's always below 0, right? So y is less than or equal to 0. My domain was less than or equal to 0 in the original, so therefore the inverse, they swap places. See if the same holds true for x and y intercepts. If I'm a betting man, which I'm not, but if I were, I'd say yes, it's going to work. So my x-intercept, sitting there at -5. So -5, comma, 0. And then for my y-intercept, it looks like it's going between the 2 and the 3, which is the square root of 5, or negative rather. So we're going to have 0, comma, negative root 5. And we can figure that out by setting it equal to 0 and solving, but we do know that those are going to swap. All right, there we go. Inverse, figured it all out, dealt with that pesky domain restriction. Definitely the trickiest part of these is remembering if it's negative or if it's positive. But again, the graph, you can absolutely see when it looks off. Okay, you know something's off. You're like, that does not look right. Either I drew this terribly or something's wrong. So that's where also it comes in really handy to scale these things out properly if you're not given graph paper, to make sure that stuff looks right. Because if it's like all jacked up on the scaling, then it might not look like it reflects when it should. Okay, let's come on over here with this one. Let's see here. We got to find my inverse. I will do so in pink once again. We'll stay consistent here. So first thing I like to do, we got y equals, x plus 4 squared. And this one is greater than or equal to -4. Greater than or equal to, so we're probably thinking, hey, it's going to be a positive square root this time, right? We'll see if that all checks out. It will, but we'll work through the steps. So now I've got x equals, parentheses, y plus 4 squared. I'll go ahead and square root at this point. And now I'll switch this around to y plus 4 equals plus or minus the square root of x. And then I got to subtract 4, so we get y equals plus or minus the square root of x minus 4. Now, we said since it's x is greater than or equal to -4, we're thinking it's going to be the positive version. So I will go ahead and just write that out in that way. G inverse of x equals square root of x minus 4. We'll see if that all checks out, if all looks right when we graph it, that we made the right decision, right? So I'm going to go ahead and plot the blue one right here. And hopefully we're okay with without writing down a table of values here and be able to calculate some of these things in our head. It definitely helps. If you need to jot down a table of values, we can. I mean, I can do it in this. You guys want me to do this? Show of hands? Okay, I'll do a table of values in this one. All right, so for here, we've got when x is greater than or equal to -4. I'm going to go ahead and throw down a table of values. I'll do so right. We'll do it here. x, g of x. So we'll start with -4. Then I'll do, how about -3? And we'll do -2. Okay. So if I plug in -4, I get 0 squared is 0. If I plug in -3, I get 1 squared is 1. And if I plug in -2 plus 4 is 2 squared is 4. So -4, 1, 2, 3, 4, 0. -3, 1. -2, positive 4. And I'm going to have this guy looking like this. Whee! Cool. Now, we'll do the inverse. We can just swap our x's and y's. I will still write out this wonderful t-chart here for you guys, since the show of hands said, yes, we want the t-chart. The people have spoken. The people have spoken. So if we swap just our x's and y's, it'll be 0, 1, and 4. Here will be -4, -3, and -2. And we can even see this will check out. Watch. If I plug 0 in here, square root of 0 is 0. -4 is -4. If I plug 1 in, square root of 1 is 1. -4 is -3. Plug 4 in, that's going to be square root of 4 is 2. -4 is -2. Right? We're going to want to pick perfect squares if we're dealing with a radical. If we're dealing with something squared or quadratic, really doesn't matter. We just don't want the numbers to get too big to go off our graph. So let's plot these things. 0, -4. We got 1, -3. And we got 4, 1, 2, 3, 4, -2. Graph it. And that is also looking, I'll draw the line in. Hopefully you see it right now. Maybe you don't. It's okay if you don't. Boom. Looks like it reflects across that to me, right? Pew, pew. Yes, sound effects are needed here. They are a must. They are a must. All right, so there we go. We got our graphs, little table of value action. Let's get our characteristics here, domain, range, x, and y, intercepts. I'll start with the original, blue. So my domain here was given to us, right? X is greater than or equal to -4. What's my range? Well, my range is always above the x, or including 0 and above. So we're going to be y is greater than or equal to 0. How about my x-intercepts? Well, it's chilling at 1, 2, 3, 4, -4, comma, 0. What about my y-intercept? Interesting. How do I get that? Well, if I plug in 0 for x, that'll always give me my y-intercept, right? If I plug in 0 here, 0 plus 4 is 4. Squared is 16. So we get 16. Don't forget your basics, all right? If I want a y-intercept, throw 0 in for x. If I want an x-intercept, put 0 in for y, a.k.a. set this thing equal to 0, okay? Last part here, inverse. So for my domain here, I'm greater than or equal to 0, which happens to be my range here on that one, but it is x is greater than or equal to 0. Look at that. I drew an x this time. I wrote an x. Not so much there. Range. I'm always above that -4 right there. Oh my goodness, did that switch with that one as well? That's crazy. It's crazy. X-intercept. Let's see, when's that thing going to cross? I don't know. Well, if I were to set this equal to 0 and solve, right, I'd have 0 equals the square root of x minus 4. Add 4. Square root of x. Square both sides. Oh my goodness. Is that going to equal 16? It does. So we get 16. Whoop, comma, 0. And then my y-intercept is at -4, so 0, comma, -4. Look at that. Swapped. 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 X's and Y's switch. Ordered pairs. X's and Y's switch to get our function, or our equation that is hopefully a function. Swap our X's and Y's. Resolve for Y. Right? It's going to reflect over the line Y equals X. A lot of common themes here, guys. X's and Y's switch when we're dealing with inverses. There we go. That's awesome, man. It's a lot of math right there. Hopefully you guys liked it, and also liked it. Click, right? And subscribe it. And then also share it with your friends. Spread the love, okay? Spread the knowledge here because math is fun. It's dope, awesome, and wonderful just like you guys. All right, see you later.